So last but not least, let's find the area. Under the standard normal curve. And let's find it in parts. Obviously the whole thing is 1, but how much are the parts of it? If I were to sketch a normal curve, give you the mean in the middle, -1, -2, z-scores up here. So I was trying to figure out what if it was, the last one I just did was, I believe, 2 standard deviations and greater. And the percentage was 2.5% of the people would be higher than 2% or higher than a z-score of 2. Let's talk about what if it didn't land like a perfect number. Like, what if I wanted you to find -1.72. That's where -1.72 is. Let's say I wanted you to find below that value. So we can't really use that 68, 95, 99.7 rule for this. You actually need that chart that I was distributing to you before. And if you look on page 4 and looks like page 5, the chart gives the area to the left of the line. And if you look, there is a column for Z, but it's only 1 decimal place. There is columns for the hundredths place. So for example, look for -1.72. You're going to want to look on page 4 because that's where the negative values are. -1.7. So what you're going to be looking for is when there is a z-score that is smaller than -1.72. Because technically you don't actually have to receive a figure to reflect on. I can just give you a question like, find the area. So you want to look for a z-score of -1.7. And if I look at that -1.7 in the chart, and if you look to the right, there's 0.00, 0.01. These are your hundredth place. 0.02, 0.03. You want -1.72. So you want the one in this column. If I look at what it is, here is would be that the area equals 0.0427. Or there's no chart that gives you the area to the right. You have to keep in mind that in a standard normal curve, if you are calculating here, which is -1.72, if you want to find the area, there is no separate chart. But keep in mind, the total area under the curve equals 1. If the area to the left we just figured out equaled 0.0427. So we can actually subtract these two numbers and we would be left with the area to the right. A lot of mistakes happen where students are asked for this area to the right and they accidentally give this small number 0.0427 because the chart is showing that value. And they're halfway there, but they're not correct because they have to actually take it away from 1. That's why we had to learn density curves beforehand so that you get the idea that the total area underneath is 1, and then if we have one part, the other part would be 1 minus it to get the remaining score. One thing I'd like to do next is just maybe try to work backwards. So let's say for a second one, I don't actually have to give a graph for it at all. I could just say that area to the right of Z is 0.20. What's Z? So you can envision this graph. So the area to the right of Z is 0.20. So that means to the right. The only problem is that my chart is telling me only what's to the left. So if it's 0.20 to the right, then it must be 0.80 to the right. No, I'm sorry. If it's 0.20 to the right, it must be 0.80 to the left. So let's look at our chart and see where 0.80 lands. And that's why it's nice to look at this as paper. It's definitely going to be on page 5. And what I'm looking for is right where 0.80, where I see 0.80. And again, we want to do it just as close as possible. So when I'm looking for 0.80, I'm looking for it in the center of the graph, somewhere within the graph. I'm not actually looking for 0.8 or anything like that. Although it does kind of end up in that spot. If I'm looking at the chart, it says a Z-score and it says 0.8. I see 0.04 and 0.05 are the closest. 0.04 is 0.7995. 0.05 is 0.8023. I'm going to go with this one, which would be a Z-score of 0.84. Because to me, it looks like it's closer to 0.7995 than it is to 0.8023. I want just 0.8000. So that's how you can work backwards. And you can also find values within. You'd have to do some subtraction, moving things around. Let's check your understanding.